Good evening, everybody. Today we are going to discuss on a very interesting subject for stainless steel manufacturer, that is on optimization of the AOD refractory lives by taking judicious steps. Is it not a very interesting subject? The most popular process route in SS manufacturing is either EAF, AOD converter, LRF optional. Next step of flowchart could be billet or bloom or slab caster, or induction furnace as a primary melting unit, primary melting station, AOD converter, LRF optional, then billet, bloom, slab caster. Out of every station activities, AOD refractory lives is most important in the context of the refractory cost per ton. We need to understand the refractory first, then we shall try to understand the treatment. Why it is important to understand refractory? The reason behind it, the composition, properties, strength, weaknesses, etc. The treatment towards refractory can be decided accordingly. It's like wearing a suitable cloth as per the temperature, humidity, dryness, chillness, etc. In a nutshell, we are supposed to not to wear very light, well-circulatory shirt in a chilling winter day or night. So the compatibility of the treatment is important for the health and the lives of the AOD converter. The treatment towards refractory. The very first point is preheating. After the lining gets over, the rate of heating and total heating time required for preheating, reheating the vessel. Always ask the refractory supplier to cater these data. We should not presume anything, especially the duration of the heating and rate of heating, in predetermined ways. The lining thickness, the mass, and the volume are important to decide the rate and the timings. Typical burner specification is 70 degrees C to 100 degrees C per hour. Rate of heating and 24 hours is the total time of heating. Heating timings with a pre-scheduled soaking based on the thickness of the refractory masses. It's highly recommended to request the preheating schedule to understand from the refractory supplier. Every organization do have practices, design or based on the masses. Kindly discuss with an expert what should be the burner specification, like type of fuel, calorific values, length of the flames, heating rate, combustion and heat losses, post-combustion, and relevant issues should be taken into account. Next important point is gas control. Once the complete new vessel taken into operation, the another most critical part is gas control. It is not so simple. People do have a presumption that in plant X, the line pressure in the shroud line is this much and the back pressure was this much. So let's do accordingly. But selection of 2 years, ferrostatic pressure, line pressure, gas flow, metal temperature, height of the bath, and above all, nozzle shape and size are the primary considerable factors. Here, this is a schematic diagram for the axial distance from the outlet of the tuyer, and you yourself can see the different tuyers behavior as per the flow rate and the pressure as gas fractions. It needs an AOD converter person who understand gas management followed by nozzle formation. In real sense, the small presentation is not sufficient enough platform to explain the nozzle management. It is an expert's job. My understanding is again for bottom blowing ASM converter, side blowing AOD converter. The flow and pressure along with tuyer selection are a technology besides of grade of steel and oxidation rate. We need to design the process and the additives in such a way that the nozzles should be healthy in the context of length and shape. Ideally speaking, 3 to 4 inches length and approximate 50 mm in diameter is the target of the nozzles, which will be protecting the tuyer's adjacent areas, whether bottom or side blowing, by its own characteristics. The metal and slag kinetics are not supposed to come in contact of the tuyer's adjacent refractory. So nozzles are important to the stainless steel makers, and careful studies on the gas control are extremely relevant to obtain a good refractory lives. Third important point is slag control. The most paramount area in optimization in refractory lives is slag control. This is essentially one of the neglected areas in most of the SS shops. But there are shops who empower their knowledge best by hiring truly knowledgeable guys who understand the good slag making followed by good steel making. Slag making is one of the key areas in SS manufacturing process metallurgy. Let's try to understand the slag, which is not just composition but the kinetics. Kinetics is the terminology of the slag composition, temperature and viscosity, all the three. Now the question arises that what composition is ideal to obtain a good and reasonable refractory lives. In a typical practices, the slag shall bear a basicity in the following way. Calcium oxide and silicon dioxide ratio can be called as V1 should be more than 1.6. Calcium oxide plus magnesium oxide is in the numerator and silicon dioxide in the denominator should be called as V2, that should be greater than 1.7. Actually, these are numbers, cannot signify the actual status of the slag compatibilities towards COD refractory. Our designed slag shall bear a composition which becomes compatible on the dolomite refractories in the AOD converter. If the temperature is 1670 degree to 1690 degree C, then the V1 and V2 can be workable in lower end. But if the temperature is above of 1700 degree to 1720 degree centigrade, then the V1 and V2 should be on higher end so that the slag cannot erode out the refractory. These controlling activities are not so simple. Slag can be defined through ternary phase diagram of isothermal solution at different temperature. There is no shortcut in these exercises, and understanding the slag is most delicate process, hoping that the little information on slag will help the steel makers thirsty to understand the slag with clear concept. Temperature control. Higher the working temperature, higher would be the challenges. What should be the correct temperature to obtain a good life statistics? This is directly proportional to the grade of steel processed. Compositional aspects of the elemental concentration like aluminium, silicon, manganese, chromium, carbon, iron, etc. The additives quantities and sequences, the oxygen flow rate and the selection of ratio, inert gas flow and the pressure synchronization, slag kinetics, slag mineralogy followed by heat conductivity, etc. It requires to understand every bit of the process metallurgy to control and maintain the temperature in every steps. Ideally speaking, to maintain the temperature within ranges less than 1700 degrees C is a safe working temperature, as of designed slag will be playing an important role in this regard. 1700 degrees C can be an unsafe temperature if the slag been designed with less quantity of fluxes. If the slag in the desiliconization, decarbonization, reduction slag would be designed in incompatible manner, then based on the temperature management, the slag will be eaten up, the refractory based on its composition and temperature. So it's a vicious circle. Time control. We need to understand that the primary control parameters are gas control, slag control, temperature control and time control. The time for the heat processing are not simple. The oxygen flow designing either in the tuyers or through top are important. Heat can be processed within 2.5 hours, 2 hours, 1.5 hours, 1 hour, or even lesser than that. It all depends how fast the oxygen flow rate is designed along with the designing of the additives for controlling of the temperature. Besides of the gas flow designing, the CRE, carbon removal efficiency, and CRR, carbon removal rate, are the most important parameters to control. With the proper CRE means the optimum usage of the oxygen for the sake of easier or faster carbon removal so that time of the heat processing can be optimized. For the said purposes, we should become very careful regarding metal height, number of two years type, gases flow and pressure, additives percentage and sequence of addition, higher quantity of gases for faster percentage of carbon removal, etc. The time management at AOD is a complex exercise and it's possible to make a grade of steel in less than an hour time. In the conclusion, aforesaid 4 important points we must follow to obtain a good life statistics, but to be very honest, refractory life improvement starts from cell designing. The specific volume of the cell before and after refractory lining plays important role to control the metal or slag kinetics. Besides of these macro cares, we need to understand be friendly to your refractory, it will be friendly to you. So every small step should be understood in the context of refractory engineering. Hope this small presentation will enable the steel makers to understand the refractory engineering more profoundly. Thank you very much for your time and patience. If you have any query, please post in the comment section. I will be thankful to you. Thank you very much to all.